Yo, what up? It's your boy, Mr. E. And today we're going to learn about least common denominators. We are moving into a new unit of fractions. And what we're specifically going to take a look at is how to add and subtract fractions with unlike denominators. So let me tell you a little story. I feel like you can't explain fractions without using pizza. Kaylee, my wife, and I love eating pizza, although I will say I would probably prefer wings. But it wouldn't really make sense to explain fractions if I used wings. So we decided that we were only going to eat a little bit of the wings because we're trying to be good because we're trying to eat healthier. So Kaylee will eat this much of the pizza, and that's how much I will eat. Of course, I got to eat a little bit more because, I'm a big boy. If we wanted to find out how much we ate altogether, that would be a little tough because we couldn't really compare how much pizza we ate because our sections look a little different. Kaylee ate 1/4 of her pizza, while I ate 1/3 of my pizza. If only there was a way that we could compare these more evenly so we could find out what the total amount of pizza was eaten. Well, there is a way. We could cut these pieces of pizza into equal slices. And what we would do is we would change these fractions into equivalent fractions. So instead of 1/4 and 1/3, we would have 3/12, which is equivalent to 1/4, and 4/12, which is equivalent to 1/3. Now that we have a common denominator, this is easy peasy to add. Instead of that question mark, we've got 7/12, which makes sense that we ate a little over half of the pizza. So what we just did here is something called finding the LCD, which stands for least common denominator. Let's dive a little bit deeper in what this actually looks like. So we have an equation here, 1/2 minus 1/5 equals W. So our first step is that we're going to stack the two fractions on top of each other. So we're going to put the 1/2 on the top and the 1/5 on the bottom. By the way, I know that we did an adding example with the pizzas, and now we're doing a subtracting. What we're going to learn is that adding and subtracting are pretty similar when we use fractions. All right, so we've stacked the two fractions on top of each other. Now we're going to make a wick column with the two denominators. Now, a wick column looks a little bit different for fractions than it did when we were dividing. What we're going to do is we're going to take the denominator of 1, so the 2, and then we're going to find multiples. So 2, 4, 6, 8, 10. Okay. I usually like to go up to at least 5 multiples, but sometimes you have to go a little further. And then we take the denominator of the other fraction, 5, and find 5 multiples of that. 5, 10, 15, 20, 25. So step 3 is to find the smallest number that matches in both columns. This will be your new denominator. So the number that matches in the column is 10. Sometimes you'll have more than one number that matches, but you're going to want to use the smallest one so you don't have to do more work later down the line. So 10 is going to be our new denominator, but we've got to make an equivalent fraction that has the denominator 10. So what we're going to do is we're going to multiply the numerator and denominator by the same number. So basically what we're doing is we're not changing the value of our fraction, we're multiplying it by 1. And if you multiply anything by 1, it's going to be itself. But we're going to change that 1 to look like something else. Couldn't I say 1 is also 5/5 or 2/2? Any number over itself is equivalent to 1. So that's why when we're trying to find an equivalent fraction, we're basically multiplying by 1 because we're not changing the value of it. We're just finding an equivalent fraction so we can add and subtract a little easier. Once we multiply across, we're going to rewrite our equation with equivalent fractions. And don't forget your operation. That is something really important. A lot of 5th graders will forget to bring the operation over. We're subtracting here. We don't want to add these two. That would be a bummer, okay? Now that we've rewritten our equation, we are going to add and subtract the numerators only. We'll leave the denominators as they are. I think that's something you learned in 4th grade, that you don't want to subtract the denominators. We're just going to leave the denominator as it is and subtract the numerators. So 5 minus 2 would give us 3. We keep the denominator the same. So our answer is 3/10. But I always say to my 5th graders, are we done yet? And the answer is no. we need to check if we can simplify our answers. We want to see if we can find an equivalent fraction that has smaller numbers. Again, not changing the value of the fraction, but finding it so that it's a little bit easier for us to read. So what I like to think is we're going to try to divide both the numerator and denominator by the first 5 prime numbers, which you should have memorized, which are 2, 3, 5, 7, and 11. I know 3 is not divisible by 2 because it's an odd number. I know 10 is not divisible by 3. 10 is divisible by 5, but 3 is not. 7, no, and 11 doesn't work. So our answer is simplified. We got a good answer, okay? So these are the steps to help you find a least common denominator and then be able to add and subtract a fraction that maybe doesn't have a like denominator at the beginning, but once you find the least common denominator, you're going to be able to add and subtract very easily. All right, let's get into a couple problems. We've got 2/7 plus 1/3. So we're going to stack them on top of each other, 2/7 and 1/3. And we're going to make a little bit of a longer line, and we're adding, okay? So we're going to make a what I know column, okay? And remember, it's a little different than what we do when we do division. We take a look at our two denominators. We've got 7, so we'll do the first 5 multiples. So 7, 14, 21, 28, and 35. And then 3, we've got 3, 6, 9, 12, 15. So something I'm noticing right away is that we don't have a common denominator here. So what we're going to have to do is we're going to have to go a little further. So we're going to go 18, 21. Oh, look at that. It just took a little bit more time, okay? So 21 is going to be our common denominator. But now we got to think, how am I going to get to 21, okay? So what I'm going to multiply by is 3 over 3, because 3 times 7 will give me 21. And I'm going to multiply by 7 over 7. So my new fraction, my equivalent fraction, will be 6 over 21. And down here, it'll be 7 over 21. Okay? And don't forget to bring that operation over with us, okay? So something cool is you can actually always find a common denominator if you just multiply the denominators together, but it might not always be the least common denominator, and that's where you're going to have to do more simplifying at the end. And simplifying is not a whole lot of fun to do, so I would try not to simp if I were you. You get what I'm saying? So 6 plus 7, that would give us 13 over 21. And then we check if it's divisible by 2, 3, 5, 7, or 11. What I notice though, and this is as you get better with prime and composite numbers, is 13 is actually a prime number. So since it's prime, it's only divisible by 13 and 1. So unless 21 is divisible by 13, which it's not, we're good to go. So this is simplified and we got a good answer. Let's move on to the next problem. So we've got 2/9 plus 1/3. Now, as I'm writing this out, I'm feeling pretty good about it because I do know that 3 goes into 9. So our what I know column is actually going to be pretty easy. We're going to go 9, 18, 21, 21. Mr. Reese needs to get some sleep. Staying up too late making these math videos. Not 21. Not everything's a meme, Mr. Ellsbury. 27, 36, 45, then 3, 6. Oh, look at that. We found a common denominator. Now, I know as you're watching this video, some of you guys are like, Mr. E, come on. I know that's going to be 9. Okay? So this one's not going to need to change because we already have our common denominator of 9. So this one will say 2/9. But what this one will do is we're going to have to multiply by 3 over 3 to get us 3/9. And then remember, we're adding, so bring that over. 2 plus 3 equals 5 over 9. Check if we can divide by the first 5 prime numbers, 2, 3, 5, 7, and 11. 5 is a prime number again, so because it's prime, unless 9 is divisible by 5, we can't simplify it. So we've got a good answer. One more problem, then we're done. So we've got 1/2 on the top, minus 1/4. Again, this one's going to be pretty easy. It looks like we're going to find a common denominator real quick, okay? We make our what I know column. Now, again, I'm sure this is pretty obvious, like what the common denominator is going to be. But I would recommend writing out these multiples, especially as we start working on harder numbers, okay? So 2, 4, 6, 8, 10, 4, 8, 12, 16, 20. Common denominator is going to be 4. We had to multiply by 2 to get to that. So 2 over 2, multiply over 1 over 1. Okay. Our new fraction is going to be 2/4, which makes sense. 2/4 is 1/2, their equivalent, and then 1/4. And we're going to be subtracting these bad boys. Okay. So 2 minus 1 would get us 1. And since we have 1 in the numerator, that's a unit fraction, and unit fractions cannot be simplified. So check mark. I will warn you guys, though, the simplifying process isn't always that easy. It's not always just like, oh, we're good, we're done. There's going to be a lot of problems where you're going to actually have to simplify. I did try to use a couple of easier fractions as we first started to learn, okay? So what I know columns, yet again, really, really important in math, so let's make sure that we're using them. And yeah, fractions can be tough, guys. I understand that, but we're going to get lots and lots of practice in, and we're going to be pros in no time, okay? If you have any questions, ask your teachers because we're more than happy to help you. All right, y'all. We love you. We miss you guys, and we'll see you later. Bye.